Good afternoon and welcome to Webinar Wednesday. Today we are joined by Dave Heiselt, Managing Member at QRS Solutions, and Owen Liu, Director of Business Development at Datrend Systems. Webinar Wednesday would like to thank our sponsors, QRS Solutions and Datrend Systems. For more than 10 years, QRS Solutions has been providing their customers with precision calibrations and metrology services, training and innovative biomed clinical engineering testing tools designed to validate the operations of medical devices. For more than 30 years, Datrend Systems has been focused on creating and automating biomedical instruments and solutions for hospitals, clinics, third-party service organizations, and medical device manufacturers around the world. For more information, please visit qrs-solutions.com and datrend.com. Just a quick reminder that TechNation is headed to our Spring MD Expo at the Woodlands Waterway Marriott Hotel and Convention Center in Houston, Texas, next month, April the 11th to the 13th. Join us for 3 days of education, networking, and the latest advances in medical technology products and services. Registration is open, so for more details, please visit mdexposhow.com. Also, please mark your calendars for our HTM Mixer, which is being held at the Turf Valley Resort in Baltimore, Maryland, from May the 11th to the 12th. Our mixers are a slightly modified, smaller, shorter duration and less crowded event that still provides valuable continuing education, networking and vendor engagement opportunities. For more information and registration details, please visit htmmixer.com. Okay, today's webinar is eligible for 1 CE credit from the ACI, and you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. Let's kick off today's webinar by giving away one of our Webinar Wednesday t-shirts to the attendee that can tell me the answer to the following trivia question. March is National Peanut Month. Which state is the largest producer of peanuts? Answer now using the questions feature on your dashboard, and I'll reveal the answer at the end of the webinar. We'll wrap up today's presentation with a live Q&A, so please submit your questions anytime using this questions feature on the dashboard. As I mentioned earlier, our presenters today are Dave Heiselt and Owen Liu, and they will be discussing efficiency through automation and multi-device integration of biomedical test equipment. Dave and Owen, you may begin whenever you're ready.
Thank you, Linda. Hello, everyone. Thank you all for taking time out of your busy schedule to participate in today's Webinar Wednesday. My name is Owen Liu. I am one of the business development directors here at Datrend Systems. Started in 1988, Datrend is an ISO 1345 certified company focused on developing and manufacturing leading-edge biomedical instruments and solutions for hospitals, clinics, third-party service centers, and medical device manufacturers. During my first stint with Datrend some 20 years ago, I had the opportunity to work through several different departments, including calibrations and engineering. When I came back in 2016, I settled into my current role to meet with customers and look for solutions to their day-to-day challenges. I'm joined here today with my co-host, Dave Heiselt from QRS Solutions. Dave?
Thanks, Owen. Well, I've worked in the HTM and biomed community now for over 20 years. Most of my time has been spent supporting through calibration service and test equipment sales, but the past several years have been focused primarily on training and integration and have resulted in wanting to share the benefits and return on the investment we have found at QRS through test and measurement automation. It seems so essential now that we live in a world of quote unquote big data, we might as well put it to use in our world too, to help us with accuracy, repeatability, ease of training, and so much more in our day-to-day decision-making processes. After hearing the repeated question from our customers of how do we do more PMs without additional FTEs and no overtime being approved? Well, as a business owner, I too face similar types of questions, and the answer was efficient testing through automation. And that was what we are now sharing with others.
Thank you, Dave. Today, we'd like to discuss with you the efficiency through automated and multi-device integration of biomedical test equipment. And of course, our agenda, we will open with background in test equipment automation, what equipment automation is already capable of today, and followed up with a live demonstration of a modern system. It has been more than 7 years since we hosted our last webinar Wednesday on principles of medical device maintenance automation. To this day, this is still the most viewed video on the MD Publishing YouTube channel. If you haven't seen it, it is a great starting point to gain a better understanding of requirements and principles. Some of our industry veterans in the room today would certainly remember the Dynatech MedTester 5000 and its accompanying CMMS software, the Sentinel. Both are early representations of CMMS and equipment automation. In fact, in my travels, I still occasionally see MedTesters being used today, even though that analyzer is from 30 years ago. Although the PM procedures were created inside the Sentinel software on a computer, note that running those PM procedures do not require a computer to be connected. The actual PMs were sent to the MedTester, and the techs can run the PM procedures independently of a PC. After the tests are completed, the MedTester can again be connected to a computer and send the results back to Sentinel to close out those work orders. CMMS systems, of course, have come a long way since Sentinel. Today, many hospitals in the United States are already using CMMS software in their facilities. They vary greatly from locally managed server client type systems to full cloud-based SaaS solutions. Some hospitals use CMMS to merely track asset inventory, while others have fully integrated them to their testers and analyzers. But despite the technological advantages, mass majority of CMMS-enabled hospitals are doing a ton of manual entry. Their day might actually look like this. First, someone would generate work orders created in the CMMS software. They take paper printouts of their test reports, often photocopied. Then they would have to test with their analyzers and simulators and fill the results as they go. Finally, at the end of the day, our techs are re-entering their test results of each measurement from paper copy back into a computer to close out those work orders. From talking to customers, this administrative time can consistently amount to 1.5 to 2 hours each day. And yet, I have never met a tech that loves data entry as part of their job. Wouldn't it be great if some of that time can be saved and applied back to services and repairs? As a biomed or running your department, you're often faced with added workload without the opportunity for additional FTEs or overtime. It is always a struggle to find the resources to keep up with the ever-increasing PM workload. By finding better automated systems and reducing administrative time, perhaps there is an opportunity for you to go back to the job you had signed up for, tinkering, debugging, and repairing. And this is the knowledge we would like to share with you today, that through automation and integration, you can save time through efficiency. Before we go further with the discussion of automation, it is important to define what some test equipment can already do today. We will call this the ladder of automation. At the first level, we have the all-important manual testing. This is when you can get a call from the OR where you needed to quickly check for basic functionality, doing a sanity check before digging deeper into the situation. Perhaps a question to think about here is, in those scenarios, will you need to be creating test reports to show what you had tested? Next, we have single device automation. This is where you're taking a defib analyzer or an electrical safety analyzer to run through a set of tests consistently. Ideally, everyone on your team can use the same sequence whenever they're testing the same make and model. For example, electrical safety testing of a Class 1 device with 3 ECG leads and 2 paddles. Above this, we have automated testing with multi-analyzer integration. Julio from Pronk had demonstrated this a few weeks ago. This is where he used their software application to control Datrend's Phase 3 defib analyzer, stepping through PM checklist and confirming SpO2 simulation output, ultimately combining the results together. Next, we have the advanced automation. And this is where things start to get really interesting. At this level, users can expect to control multiple analyzers or simulators in the same test sequence, such as patient simulation, Untitled CO2 simulation, defib testing, electrical safety, and so on. The procedure might prompt the tech to select between different test sequences, for example, regular PM versus a post-repair test sequence, perhaps including calibration information of the testers you had used, such as a multimeter or scope for better traceability. Maybe you're testing a device with an optional module, but the module was removed by someone and sent away for service, so that the tech needed to determine if more or less testing was needed. But this decision was made during the test sequence itself. Or maybe you wanted to include instructional pictures, videos, or documentation to reference as part of the test. Great tools for helping new members of the team. Finally, we have data integration or CMMS integration. This is where your test equipment can download from CMMS systems directly, the asset database, the procedures, and checklists. Then after all the tests are completed, internal pass-fail codes, tech ID, along with other CMMS required fields are sent back with a full test report to close out the work orders automatically, without having to re-enter the test results or connecting to a computer. So a question to our attendees to think about: where in the ladder of automation are you at today? I think to discuss automation, we must live and breathe in it. For Datrend, our journey started more than 20 years ago, where our electrical safety analyzer was able to communicate with CMMS systems, at the same time, communicate and control other testers and simulators, automatically pass-fail functionality, network connectivity, connection with barcode scanners, label printers, and automatically merging those test results into a single test report. Although the system worked well, it still required a connection to a computer to complete the download and upload. There must be a better solution. So DNI Nevada started working with Datrend on the next generation of test equipment, codenamed VisionPad. At the time, however, we didn't have the technology to support our vision. Then around 10 to 15 years ago, tablets and smartphones came to the market. Revolutionary for its capabilities at the time, today we see them used in all levels of our healthcare system and growing. So around 2010, Datrend started developing and releasing a new line of tablet-based test equipment, and in process, created unique apps to support our customers' vision in automation. Naturally, VisionPad was shortened to VPAD. We sincerely believe this is the direction the industry is moving towards, as other manufacturers have recently added Bluetooth connectivity and apps to their product offerings as well. For the demonstration today, we will start with VPAD EQT. It is a starting point for many of our customers after synchronizing asset and procedures from their CMMS system. Once the auto sequence starts, we will initiate a call to our ESU analyzer to continue with the PM checklist and ESU function tests. Then the auto sequence will automatically jump back to the electrical safety analyzer to run an NFPA safety test. And finally, we will select the test equipment used to include in the test report and print off the optional calibration label. So now I would like to pass to Dave for the live demonstration.
Thanks, Owen. So we're going to transition over to a live viewpoint of our tablet, and I'm going to go ahead and walk you through a PM procedure.
Give us one moment here.
All right. So what we're looking at here is a live view of our demonstration tablet and some of the apps that we have available. So as Owen indicated, we're going to start off by using the app called VPAD EQM. So I'm going to select that. And when I select that, I've got a condensed list of Force FX units that we're looking at here on my asset list that are due currently for PM. I'm going to go ahead and select on one of the units to do the abbreviated PM. And then the next window you'll be looking at is a window that demonstrates the information coming from your asset management system. This gives you the opportunity to validate the information that's currently in your asset management system for accuracy. You can also see the schedule, the technician who last worked on the equipment, and so forth. When everything has been validated, you can go ahead and select on the run key, and it'll start the actual PM procedure. Again, this is an abbreviated PM. We're not going to walk through the entire PM. We just wanted to give you some samples and a taste of how a complete PM would look. So in this, we're going to start with the electrical surgical testing. So our tablet would be communicating with our ESU analyzer, and the ESU analyzer would be used for taking the measurements for the RF outputs and leakage testing, as well as providing the resistance values for REM testing. So these can be configured any way that a person wants to configure them. These are how we prefer to configure ours, to explain everything that's going to be needed during a PM and then continue on. So we can give instructions to the user, as well as have checklists and things that need to be notated or taken for pass fail. So we're going to say that we've powered it off. Now we powered it back on. So we've connected and turned it back on. After applying, we're going to verify that all the lights and indicators come back up, and that like I said, the bells and the sounds and things like that are heard. We'll acknowledge those. So we've now confirmed the power on self-test and completed successfully. We're going to move on to the REM testing. So in this case, we're providing the ability to not only give detailed visual instructions via text format, but we also offer, and again, this is one of the efficiencies that we believe is so significant, is to give the ability to add pictures. So in this case, for those that have never done an ESU PM, one of the key factors is to make sure that you have a test cable with the little pin on the test cable. So we feel that through a visual aid like this photo, you can more appropriately and quickly or efficiently give those instructions to your technician. In this case, we're using just a default sample device under test or representation of the ESU unit itself. We will have a slide also showing one with an exact unit. So if you're building a specific one to a specific make and model, you can have those in there as well. So after returning, I can check to the next step. And as indicated for REM, we're producing resistance values. So the resistance is now set automatically at 120 because of the way the procedure has been created. Now the end user can connect the REM test cable because the resistance is there, and the appropriate indication we're looking for is that the green light should turn on and the alarm is not in an on state but is off. So we're going to say that the unit indicates that. So I hit save data. I'm going to indicate that the alarm is off, and as you can see, the result automatically equals a pass because of the way the PM procedure has been built. They don't have to have a manual or anything else with them. Everything they need is right here in the procedure. At this next step, we now need to slowly increase the resistance from 120, and we are looking for an alarmed value. So I'm going to go ahead and increase the resistance. Again, I know we're simulating this here, so I'm going to say at 134, I hear the audible tone, the red light turns on, I now have an alarm. So I'm going to indicate that at 134, I have an alarm, it is on, and that is a pass because it's between 130 and 140 ohms, and next step. Next, we automatically switch directly to 60 ohms. There's nothing the technician needs to do. I merely have to hit the save data, indicate that again at 60 with a reduced resistance, the alarm is back in an off state, and next step. And again, I know we're doing an abbreviated PM example here. That's not the entire one for an FX, but I think you'll get the idea. So next, we're going to jump into a couple examples of HF or high frequency output and leakage tests. So very similarly, we can give the instructions to the user. They don't need to show picture if they already have done several of these and they're familiar with the test at this point. They can merely go on to the next step, but they can also show the image. So here we're actually indicating an additional function that we gave to this analyzer, being able to utilize the foot switch capability of the generators themselves, allowing for the VPAD RF to turn on and off as needed. The monopolar, both the cut and coagulation modes, as well as bipolar. So if this foot switch is connected, in our next step, all the technician will need to do is make sure that the additional connections for the measurements are done appropriately between the device under test and the VPAD RF. And finally, they'll need to set up the ESU from the front panel display, pressing the precise button, and at the bipolar, setting the power to 70 watts. Once they've done this and hit the next step, it indicates that from here on out, when they hit next, an automatic turning on of the generator itself will occur, and the measurement will be taken automatically. And if the result is a passing result, it gives them a few seconds to review those results before it automatically passes to the next step. There is no need for a user to acknowledge that it's a pass or hit any other additional keys to pass that step. In the event that there is a failure, the step will automatically stop and allow the user to reevaluate their setup or whatever it is that they've done. They can even use the previous step button if they've determined that they did not set it up correctly, or maybe they forgot to set the power to the correct level. They can go previous and re-perform the test. So again, now I'm ready for my next step. The unit activates automatically, and as you can see, measurements are taken automatically. They're in tolerance, so it automatically passes to the next step. Here we're going to change to macro, and we test it in macro mode. Again, we're in tolerance, so we're automatically going to pass to the next step. It's all these little things that we found that are aiding in the efficiency of the automation in PM testing. So whenever possible, we're trying to find, even if it's that 5 or 10 seconds here and there, we're at the point now where 5 or 10 seconds across, 15 to 20,000 devices really adds up. So we're really trying to get that time back and put that in the hands of our users. Our final step here is going to be to do the leakage testing, where again, now you can see we've integrated with an image of the actual Force FX, just so you can see that we can have variation or change the devices and things like that. Once it's been connected, again, we'll set it back to precise and 70 watts. The next step, and again, we're in tolerance, it automatically passes to the next step. One final step for leakage of checking the macro. Check for leakage on macro, and again, we're in tolerance and we're good there. So now we're going to return the generator controls to the previous desired settings, and we're going to move on to the next section of our testing. From here, we're able to go ahead and save the ESU test. I can review just the ESU portions of the test that we've done so far and continue on to next step, where now we're going to perform the electrical safety portion. So during the electrical safety, we're going to be plugging into the test receptacle of the safety analyzer and connecting the Kelvin cable for the ground plug. We're ready to run. It's automatically going to take over, and you can see there's no need for a user to change applications. The procedure is in control and changes to the appropriate application automatically. So if you notate at the top, we are now running an application called VPAD NFPA. This is the auto safety analyzer app that we're using that has all of the hospital limits or the limits per NFPA standards by which we're going to be testing to. So currently I'm at my line cord resistance. I can flex my power cord at the wall end and at the equipment end. When I'm ready to save my resistance value, I can hit save resistance and next step. From here forward, it's going to start to take automatic measurements in the off state, and it's going to indicate when the power is going to come back on to the unit. So we realize that now we have soft switch capability with many devices out there. So you get an audible tone and a message that says power is now applied to the receptacle, because you need to boot the unit all the way up to a fully on state before taking the additional measurements. So I've now turned on the unit, it's fully on, I'm going to continue, and we're going to take the measurements in the on state. Like with the on receptacle state, we're going to notify you before we disconnect power to the test receptacle, allowing you for proper shutdown of CPU-based units so that you don't damage the unit. So once I've gone ahead and shut down or gone through a boot down cycle of the unit, I can continue, and now the receptacle is disconnected from power. Again, all of the automated results equate to a pass. I'm going to save those results, and just like with ESU testing, I can review just the electrical safety portion and next step. And finally, we can now disconnect all of our cables and identify any additional equipment or multiple pieces of equipment that need to be added to our report for traceability. So I'm going to select that we also, in this case, use the VPAD RF, and I'm going to return to checklist. I do want to include a more non-summary based equipment, so I'm going to choose verbose. This is all the details of the piece of equipment I've selected that's going to be added to my test report. Continue to my next step, and we're now at the end of our PM procedure. So at the end of the PM procedure, you'll see I can now scroll through and see all of the steps from the VPAD RF analyzer that we used first, then through the electrical safety tests, and then through the additional equipment that we added at the end. I acknowledge that I'm good there. If you have those types of information that Owen indicated that your CMMS requires for full and a complete completion of the PM record, you can go in. These would be derived or selected from your CMMS system automatically on your transfer. So I'm going to indicate that this was a PM pass. I'm going to indicate that it took me 30 minutes for the PM, and now I'm going to go ahead and create that record. And like Owen indicated, for those that are using PM tags, we have a label printer that has the security labels on them that can be cleaned and wiped down and everything else, as well as even including a QR code for a barcode, because some of our customers have said that their hospital systems haven't gone to barcodes yet. This gives those biomed organizations the ability to create their own barcode for next year's PM or 6 months from now or whenever it is, that again aids in the efficiency of scanning last year's tag or the previous PM tag, and will get you right back to the beginning of that PM just like we started. So I've finished printing my tag, and now it comes back and indicates in green that I've completed the PM for this piece of equipment. So that goes through and shows you the efficiency in the automation of a complete PM using multiple devices and arriving at one test report to be sent back to your CMMS system for a complete PM closure.
That's great, Dave. Thank you. With more than 30 years of our continued focus on test equipment automation, we have shown you just a few of the efficiency that can be obtained through test equipment integration and automation. Before we open the session for questions, we would like to ask, where are you with your automation? Linda?
Yep, okay. We've got a couple of questions come in. First question is, where are the auto sequences stored?
That's a great question. So as Owen pulls it up, if there are things that you would like to see, because we're not just doing it from a slideshow presentation and we have a demo tablet here, we're able to walk through live and real time with you and give you some examples or show you some of the behind the scenes, if you will. So with the question, where are the PM auto sequences, and where do they live? You have to travel back in time to that 20 years ago. So as Owen indicated, with the med tester, everything was transferred from the computer to the med tester. At that point, you could disconnect the med tester from the computer connection, and all you needed to take was the med tester and any additional test equipment enabled and to be able to perform your PMs. Moving forward into the Wi-Fi age or the communication age, a lot of systems now rely heavily or solely on Wi-Fi communications. At Datrend, they felt that it was really important not to lose sight of the ability for the test equipment to be able to store and maintain all of the ability without the direct communication. Even though we use the communication for pulling the information from an asset management system and pushing it back, we found that it's kind of like with your cell phone. If you've ever been traveling down the road and you're on a call and everything sounds great 1 second, and the next second, boom, you've lost communication. Well, we're not in an age of 100% good wireless communications at all time yet. So with that being said, there could be dead spots within a hospital. We've got rural customers that say that they still have areas with little to no coverage, in those rural areas. So the need to be able to have everything on the equipment and not have to rely on the wireless capabilities of whether you can or cannot do your PMs is vital. So that's where we still maintain today. We utilize the wireless communications to be able to push and pull information back and forth from the system, but it is not required in any way to be able to perform your PMs. So for example, if I come onto the tablet and I go into the VPAD check, which is kind of where all the checklists are stored. So we've got all of these various makes and models in here. So these makes and models would then be tied to a particular asset or control number of a device. And that's how our system, when you pull up that asset or control number, because it's synchronized with a particular PM procedure, it knows to go and start that given PM that is stored locally on the tablet itself. So I hope that answers that question. That's a great question.
Okay, and the next question is, can all test equipment be integrated or controlled by another device?
Yeah, that's a good question. I mean, I think for test equipment, you have to look at the way or whether the equipment originally was built with remote control capabilities. So if you look at some of the older Metron or other testers out there, they were built with serial port or communication in mind. And if you look at those service manuals, quite often they have remote control commands or instructions. For those type of devices, yes, it's 100% because we do have the capability to send out the commands and retrieve the data or control those testers. But of course, if that particular device never had that functionality built in, of course, then it's a little bit more challenging. But I think I want to add here is, I think that's the end. That's where I want to conclude that question.
Yeah, just to add a little bit more, I mean, Owen, you pointed out that a few weeks ago, Pronk did a wonderful demonstration using their Mobilize application and communicating and connecting to the phase 3. I think that we're doing a great job of showing two companies that have the ability for communications in working together. I know that we've got many of the same types of customers who love those products that they already have. And as a matter of fact, they love the products they have of the Datrend, and they're looking for more of a merger of those two products where they would like to see some of the Pronk devices communicate and be connected through this type of automation. So we're in ongoing discussions with companies like Pronk and those that want to work with us on those types of intercompany communications. I think it's vital to where we're going.
Good. Okay. Another question here is, how much time could I save using this system?
Yeah, we have some great questions coming today. So there's a lot of different time savings that you can look at. I think Owen pointed out earlier in the PowerPoint presentation, one of the biggest time savers that we looked at from the very beginning was, as he indicated, the time being spent back at the computer or the workstation in the shops. After going around to numerous customers, we were consistently coming up with anywhere from 1.5 to 2 hours of time being spent per technician on any given day doing additional or complete documentation within their asset management system just to be able to close out that work order. And so that's where our focus has been, is to be able to give them all of the tools and additional information that they need to be able to close out those PM past work orders in the field. As we indicated at the end of our PM example, if there's additional codes or things like that that need to be completed in order to fulfill the healthcare organization's requirements for completing all of those records, we want to be able to get the lists of all those codes and things to assist those technicians to complete those right then and there at the very end of each of those PMs, so that when they pass that record back to their asset management system, it's going to tick all the boxes that they're required to tick. And now they'll only be left with the fail PMs that they need to go back and address, because maybe they need to order parts and they need to indicate that on the PM record, or maybe they need to get a return merchandise or authorization or RMA and put that information back into the system as well. Those are things that can't really be easily handled in the system. But I think we would all agree, if all of the PM pass records would close out their work orders automatically from the field, that 1.5 to 2 hours would probably go down to 10 to 30 minutes a day just dealing with any anomalies or failures. So that's an additional 1 to 1.5 hours per day that could be spent either on additional PMs or, as Owen indicated, working on repairs, which is why most of us signed up to be technicians. So those are the types of time savings. There's additional ones that are harder to quantify because a number of our customers have indicated that while they purchased it for time savings, having such an easy path forward for doing a more complete PM has actually driven them to doing a more complete, more consistent job with every technician every time. So in some instances, they made a trade-off of time. Instead of spending maybe 10 minutes a PM, it's now taking 15, but they're actually doing more work during that PM with more information being included, and every technician is doing it the same way every time. So they've opted for maybe even spending a little more of that time savings to provide their customers with what they felt was a better product, being, more complete, full reports and things like that. While again, others have stated that, for example, on ESUs, maybe because they have to have a service manual out and following along line by line, it's taking them an hour and 20 minutes to get a particular PM done. We're having everything that they need already built into the PM. Now they're able to get it done in 45 minutes consistently. So again, there's time savings there. But again, that side of things is a little harder to quantify. We've also had a number of customers that have come back to us and said that they completely changed their training matrix. So instead of, feeling like they need to try and send everybody out to all these different trainings, they've come back and said, we now just focus on our PMs. We have those that have been sent to particular manufacturer trainings, work with our team on making sure that we have the best PM procedure possible. And now they're bringing in new technicians and they're able to just train on test equipment. And that has significantly reduced the amount of training time because they know if they can have a new technician go through the procedure and have no issues, then they just have to teach them how to operate that test equipment and they should be ready to hit the field. So the time savings on training can be significant as well. So I'm glad somebody asked that because those are some great examples of additional efficiency and time savings and automation.
Okay, so is this system being used in the field currently?
Absolutely. Actually, we have actually just a number of customers. I rejoined Datrend in 2016. So since that time period, I've had the opportunity, at least in the United States, being able to visit numerous hospitals through Dave QRS and of course, and again, everybody's has a different story. We've seen different CMMS systems being implemented from EC2s to Minimizer, AIMS, and new Volos in there now. So it's all about how far the customer wanted to achieve automation, but there are numerous sites that we already have now that they can use the device to download their work orders, do all their testing, and then of course, like Dave has said, upload those results back at the end of the day, and taking 10 minutes instead of doing actual typing into a computer.
Yeah, I mean, since it's kind of our bailiwick here in the U.S., I mean, we've got from 2 and 3 man mom and pop third party shops that have embraced the automation and integration to entire U.S. based healthcare organizations that have standardized across the board on it because of the time savings, automation, consistency. It really ticked all the boxes that they were looking for. Again, they really wanted big data, and this allowed them, as they pointed out to us, if you really want to be able to utilize big data in a positive way, number one, it's garbage in is garbage out. So the first thing you need to look at is having the most accurate, consistent data going into your system as possible so that that you can rely on the data that you're now using to make those key decisions in your organization.
Dave, do you think we can go back and maybe just quickly show what a process will look like for somebody wanting to get some information from a CMMS system?
Sure. So I'm going to go ahead and show all. I'm not picking anybody by favorites. I'm just going to pick one of the oldest and longest systems out there, being Metamizer, because I think this will give you an example of how quickly and efficiently. So this would be tied in with a hospital system's Metamizer server. We'll pretend that it's the first day of the month. On the first day of the month, I really need all new information. So if you're following along in the top right-hand corner, I just selected that I need to get all equipment, including anything new that was added since the last time I ran this, any new procedures or task items, and all open work orders. So once that happens, I can go ahead and hit the Get Data button. It would reach out to my asset management system, again, in this case being Metamizer, and it would collect all that information. And now I'm ready to start running those PMs. At the end of your day, or we've actually found, because a lot of people utilize dashboards now, technicians tend to be a little paranoid that somebody is spending the entire, part of their day doing nothing but looking at those dashboards and, who's working and who's not, even though I still haven't seen anybody that does that often. But for the technicians, because it's so quick and easy to come in here and say, select non-transferred information, and I'll select all the work orders that I've completed since the last time I transferred. I can even come in and deselect a couple if I don't want to send those back right now. And then I could say, select non-transferred files, and all of those would be transferred back to Metamizer. Again, it takes seconds, so I could do it, 5 times a day, or I could do it at the end of the day. It's really up to whatever the healthcare organization. So now it's the second day of the month, and everywhere after that, I no longer need new equipment, new procedures, or new tasks. So now I simply just want to get new open work orders. So all the stuff that I transferred back yesterday would not come through because it would be closed out, right? When I transferred those files back, those work orders would now be closed. If you have a team that's closing these, again, let's say I've got 6 technicians who are all closing them, by having the technicians each day go back and get new open work orders, all the work orders closed by the entire team are no longer on this list, and now I can start fresh with only the open ones. So that's an example of how quick and easy it is to go back and forth between your asset management system.
Okay, I have a very quick question here. I've got an attendee that just wants you to clarify what the maximum ground resistance is. He said he thought the maximum ground resistance was 0.5 ohms and not 0.3 ohms. Could you clarify that for him?
Oh, I see. So yes, so if you're testing in accordance to NFPA, that pass-fail limit is actually 0.5 ohms for the line core resistance.
And for IEC.
And what you saw in there is our pre-configured auto sequence. So that value can be configured by the user. When we run through an auto sequence, or when we configure an auto sequence, we have an option to check off passing or failing based on the limits of the standard. But some organizations over time have determined higher levels of quality or testing process internally for themselves. So they actually put down tighter tolerances and testing methods, if you will, when they're running the auto sequence. So what you saw there was just a remnants of another sequence we created before, and that is actually just got a little bit smaller value compared to the standard.
Okay, that's great. Thank you for that. We don't appear to have any more questions, so we'll wrap up now. So thank you so much, Dave and Owen, for your time today and for a great and informative presentation. I'd like to encourage everyone to visit today's sponsors to learn more about the products they provide to our industry. So please visit qrs-solutions.com and datrend.com. As promised, the answer to today's trivia question is, of course, Georgia. So congratulations to our winner, Jason Hoen. A quick reminder, you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. We'll be back next week with another webinar, so please visit webinarwednesday.live for more details and complimentary registration. Thank you once again for your time today and enjoy the rest of your day.